Welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever. Good. So last session we what did we do? We made the game compile with C++. I don't know, 14 or so. I didn't check the version. Good. So now we have upgraded to C++ 17 and it does have additional compile errors. So let's look into that. Yeah. Let's see. All right. So web browser. What is the problem here? Query interface. Overriding virtual function has less restrictive exception specification than base class virtual member function. No except. Oh. Aha. And that's an error. Oof. Okay. Okay. Then I think what we should do here, include pre-RTS. Then we remove Windows. Web browser. Pre-RTS. Do we have a macro? I don't know why the Mac OGen is spilling in here. Macro defines maybe definition. I'm not sure where I should move it. C++ 17 version macro. Okay, if C++ larger equal that. Yeah. Oh. It's 1997. Let's ask ChatGPT. How can we check C++ version in C++ preprocessor? Yeah, and this works correctly. Here it shows as this one. I'm not sure that works then. And if, okay, so we say define no excepts. no except else. Define no except. Well, that doesn't work. Why is this date? Precompiled. Do we have a folder? Include precompile. Common. How about we create a new file here? CPP version CPP CPP macros. Let's yeah, I think that's okay name. Copy protection. CPP macros. CPP macros cannot be opened. Let's go back to this function class file. Let's revert this. Let's include common CPP macros. Let's compile. Oh, there's so much text here. Publisher Electronic Arts? So I don't think so. Ah, official version, okay. Maybe we should put it even in another subfolder. Oh, I think it's fine. Okay. Okay, so CPP macros, there we go. So we do pragma once. There we go. We say the super hackers. This file contains macros used to upgrade CPP standards. To help upgrade CPP standards. Yeah, I don't know why this one shows 1997. I find this really strange. Okay, but so if we add no except here, and here, and here, then this one shows as being empty. So if we compile this, what does it do? Did we add pragma once? Yeah. Okay, it's still complaining. Let me see. The C++ solution MSVC solution, let's say a VS 2020 solution generated by CMake targeting C++ 17 reports this to be of value that. Why does that happen? Does not define correctly. Oof. Default, okay. Add compile option. Okay. Okay. Interesting. Multi-threaded builds. At do we need the quotes here? Or can we just pass it like that? Let's see official documentation, what it recommends. CMake, add compile options. No, it doesn't use any quotes. Okay. Enforce strict C++ version. Okay. Okay, let's try that then. We also still need to test all this against vs6 if it still compiles or not. Hopefully it does. Yeah. We should probably rename this to no except 17. Yeah. Yeah. We should do that. To help upgrade the code for newer CPP standards. Okay, redefinition it says. So we also need to add no except here. Let's wait until the build is done. Oh, I'm afraid of following up because there will just be so much to read, I think. Or maybe not. Well, the mappers seem to be very busy here. Okay, did it finish? Good, then we can also add, hold on, CPP macros. I would say we label this no except 17. So it will be only added to things that do this in 17. If that makes sense. Yeah. Okay. Okay, let's try that again. In the CMake, I would like to move this one down here. Oof. Which will rebuild the whole thing, and it actually worked now. Okay. So for Visual Studio 17, we got it to compile. How about we make a separate commit just for that? So this will be CPP standard 8. Oops, wait. Set C++ standard. There we go. Ah, yeah. Good. So we say this is upgrade to C++ 17. For 0-hour builds. Well, I mean, it is for the whole thing. Upgrade to C++ 17. Yeah. Okay, but we are missing something here. This one should be wrapped. If not MSVC and how do we check for the version again? We took a note somewhere, I think. Let's search for this string here. Here. Let me ask ChatGPT. Is it safe to check if less in CMake on all compilers? For all platforms, or does it need to be guarded by another condition such as MSVC? It is not safe to check on all platforms without first ensuring that MSC version is actually defined. Aha. I see. Okay, I thought so. Interesting. Okay, then we'll say if MSVC and that, yeah. Can we set how do we set a new Boolean variable in CMake? For example, to identify vs6 builds. Less equal. Okay, so we say set is vs6. Okay, so if MSVC and let's say less 1300, true. Let's call this is vs6 build. Then we say here, if not is vs6 build, then we set the CPP standard. Yeah. And if and then we can also move this in there, maybe. I'm not sure if we should move it in here. Maybe. Add compile option. Set C++ standard, CMake, CX extended 17. Ensure only ISO features are used. Ensures only ISO multi-threaded build. Enforce strict. Yeah. I mean, it depends if these options are recognized, and let's leave them here for now, and we just check it. By the way, this should be like so. Oof. Okay. All right. Let's test that. Let's see. Let's see. Hold on. Is vs6 build, and here we can also say if is vs6 built. There we go. Maybe we should rename it to something else. Build vs6. No, I think it's okay. Good. Let's see if that compiles as well. Huh. That was suspiciously fast. Yeah. Yeah. That was strange. Maybe do a rebuild. Okay, upgrade to C++ 17. Yeah, let's commit that for now. Okay, let's see what happens if we upgrade to C++ 20 again. 20. Actually, before we do that, let's compile this against vs6. We want to see if it still works against the whole thing, right? Okay, so we open CMD. We go to our script here. So we do this one, that one. We go to pass. We set this up to build everything. Yeah. Everything. Let's see if it goes without errors. There's an error. Okay. Yeah. Okay, what is the error? Target compile definitions. STL port 10. Okay. STL port. What did we do wrong? Let's see. CMake STL port line 10. Huh? Is that not correct? Target compile definitions may only set interface properties on interface targets. What? Ah. So we have to set interface here. Is that correct? Let's try that. Yeah. vs6. Okay, so configuration generating is done. That's good. Then let's do build. Wait, first need to change the folder. I wonder if there's a way to invoke this with this folder. Yeah, maybe. Okay, let's see. Oh, compile line warning. Okay, ignoring. Okay, so we need to move this block. Okay, that's fair. Let's stop the compilation. CMake lists. Okay, then we move this guy in here. All right. Good, let's try that again. I expected there will be some compile errors. If it runs through without a single error, that means we have achieved perfection. Oh, it still complains about warnings. Hold on. Why is that? CD. Maybe we should turn generals off for now. Because we didn't touch generals. Don't need to build that. Yeah, let's turn generals off. Off. There we go. Let's just build 0 hour and this tools. Warning. Build generals tools. Why is this warning about this one? I don't understand. Good, let's see. I hope for a miracle. It still complains about command line warning. What is this? Ignoring unknown option. Huh? Hold on. If not, is vs6 build. Why is it going in here? I don't understand. Ugh. Message. Message. CMake. CMake message. Status. Status building with vs6. Okay. Let me see if we get that message. I don't see it. Does it say anywhere that it's building with vs6? What about this message here? Where's this put? Message. Just message. How do we know that this is set? Ugh. Let's do the following. else. There we go. Let's put here a message. Fatal error. Unexpected. Unexpected. Let's see. There we go. Oh, oops. There we go. There we go. Okay. Okay, so it doesn't go in here for some reason. If MSVC and MSV version less, it doesn't reach this place. What? Ugh. With vs6, it does not pass the following CMake condition. Why? MSV version is not defined in older CMake versions. It's only available in newer CMake versions. CMake started defining in CMake 3.1 plus, where we are using 3.1. MSV in the compile. MSCV. Check MSV directly if MSV is missing. What the hell is that? What the hell? Why is there a rocket emoji? What is this? What is going on here? Does not define. Use. Where do we use this here? Hold on. What is it doing? Bruh. Corresponds. Prevents. What? MSC version is only available in newer CMake versions. CMake started defining MSVC version in CMake 3.1 plus. Okay, but the CMake we are using is certainly newer. CMake. It's version 3.3. So that should be safe. The CMake version I use is 3.3. Should be defined. If the condition doesn't pass, there are a few possible reasons. CMake doesn't detect MSVC properly. Not printed. CMake is not detecting MSVC. Okay, let's try this bullshit here. What is this? If defined, MSVC version and MSVC version less than that, then set true. Else, if defined this and that matches CL, check for VS. Try run. Compile result. What the hell is that? What? Run results. Matches 1200. Oof. Can we say less 1300? Less 1300? Boah, else message unexpected. Hold on. Else false. There we go. Man. Let's comment this out. Okay, what now? There we go. Okay, so now we have 2 ins and 2 outs. Let's see. Let's see. Flow control not properly nested. 44. Oh. Oh, I see. I see. If, else, and if. That should work. Unexpected. Jesus Christ. Okay. Well, that's not good. So let's try this matches thingy. Matches. That doesn't work. It was a nice try. Let's say message fatal error. Man, what is this up with this formatting here? Detected MSVC version is empty. Okay. Try running CMake. CXX compiler CL to force MSVC detection. Oof. Oof. Yeah. The MSVC version shows empty in CMake. It's not properly detecting. Specify compiler path. That's a good idea here. Let's try that. Okay, so CMake CXX compiler. Compiler ID empty, MSVC version empty. Yeah. Oof. Yeah, how do we detect that now? Oof. Check MSC Word directly. Create a check file. That's what he tried to do here, right? Check vs6. Create a check file. Okay. That's some hack, isn't it? Jesus Christ. Okay. I mean, let's try that, I guess. Line 50. No, it doesn't work. It's quite some hack, isn't it? The question is, did it create this file? Let me see. Curious. Code. Build. What's the name of it? Check vs6. Who knows? Binary deer. Probably here, but I don't see it. Breit. I mean, it's an interesting idea, but CMake binary deer. CMake binary deer. Compile result. sources. So here it put like one deer, and here puts 2 deers. What is the difference? I don't understand. Nothing happens. Yeah, I mean, it doesn't create that file. Maybe it doesn't even go in here. Hold on. CMake. Yeah, how about we say else? How about we say else? Else. There we go. Good. And then... So this branch down here, that will never be reached now. Let's remove that. Let's see. 45. Line 45 fails here. Okay. Did it create the file though? It did. Okay, let's see if it looks proper. Include iostream if in def error and if in main. Yeah. Try run. Compile result. Yeah, but how do we know that this ran? Output variable. Okay, so this one looks different than what we had before. Let me see. Oh. Let's comment this out. Let's try the other one that ChatGPT has proposed. This one. Yeah. Let's see. Doesn't work. Nope. Nope, nope, nope. That's too bad. It's too bad. Is there any other way to detect vs6 cleverly? I say let's see. Let's ask a try run, and the check behind does not appear to work. What is wrong? Let's say I see the check CPP generated, but try run and the check behind does not appear to work. What is wrong? Let's see what the ideas are. Does not set. Okay, we can add some debugging. Compile result is false. Failed to compile check. Okay, let's see. Yeah. Let's put that. Let's see what that says. It says compile result empty, run result empty. Try compile works only for enabled languages. Currently these are empty. Oh. 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 Interesting. Well, compile result is empty. Use try compile. Okay. Let's see. Try compile. Let's see. Try compile. Try compile. CMake says there are no languages listed. CMake did not detect any compiler. What? Compiler is unset. Project. My project CXX. What? Okay, so it's saying that this stuff here needs to be after the project. Let's see. Let's see if that is true. Oh, it is. Oh boy. There we go. Oh. So it has to be behind this one. Wow. Okay. 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 CMake. Let's see. So it's CXX compiler, that. Here. Okay, this one looks good. ID, MSVC, MSC version. Yeah. Let's say if defined this one, message, and if okay, then we can remove all this garbage here, I think. And we simply set this, and we're done. There we go. If defined, yeah. Mm-hmm. Mm-hmm. Print some information. Set set variable for vs6 to handle special cases. Okay. Then let's see if that works. Okay. That's nice. Good. Then we go here. And then we try build. Here. There we go. Let's see. Okay. I didn't know that it has to be done after the project is applied. But now this looks correct. Yeah. Okay. Excellent. Excellent. Good. Then let's pray to the compiler gods that this runs through. That would be much appreciated. Yeah. Very much appreciated. Yeah. We are at 7%. No error yet. That's good. 8%. It's looking promising. Promising. Good. We got some compiler error. Let's see. Oh, it's that thing. Error. Undeclared identifier. Huh? Syntax error. Oof. 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 Oh, okay. I mean, if we can't figure this out, type def ignored on left of when no variable is declared. What? What? Let's see. I mean, in worst case, we can just go back to the import thingy, the way they had it before. Why is it not showing here? Okay, what is it complaining about? It is a type def. Type def, web browser, error, undeclared identifier. Syntax error, missing, before, What? Illegal. Left operand has type construct. What? Blah. 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 What is the problem? Undeclared identifier. Syntax error. Illegal. Left operand as type. To me, it looks like it doesn't understand what this thing is. Right? It doesn't understand it. Does not understand it. Why not? Why not? Is there something wrong with the way this is written? Let me ask ChatGPT. Would this code work with vs6? No. Does not support com.iid. Older implementation. Com.ptr that does not support. Was introduced later. It's not available. Oh god. Oh god. So much does not exist. Okay. Comdef. Okay. How would you write it then? Type def. This works. Okay. Oh god. What the hell is that? Your ID here. Do we need this IID or not? Okay, smaller than 1300. If defined, msver else and if. Okay, let's move this guy down here. And then this one down here. And so what headers should I include here? What happens if we do type def this one, just this? We put just this here, and then we put comdef. Include comdef. Let's see. Yo, this better work now. Let's see. Probably doesn't because of the GUID thingy, which we maybe need to figure out. Fatal error. Oof. Okay, well, it's different. Interface is not a member. Interface. You know what? For the legacy stuff, let's just use the way it was before. So we simply go here. There we go. And we simply do this bullshit here. Which is a bit sad. But if it works, it works, right? Yeah. Okay. Yeah. Good. So we just say here, import the browser type library, blah, blah. I will leave it like this till I can figure out a better way. Yeah. Leave it like that, my brother. It's fine. It's fine. You are forgiven. Forgiven. Okay, let's do that. Oof. Copy link. I'm always interested in technical explanations. One more thing I would like to mention is that the problem with DirectX access float mode is likely a result of using D3DX matrix. So I believe D3DX problem, not a D3D problem. Providing custom implementation, the DirectX problem mentioned in the source code likely won't occur. This should be easily verified by running the original game with DXVK under Windows and seeing if it easily desyncs. If the source code is actually right, which I doubt, and the problem is really D3D, desyncs should occur as a result. Non-floats, longs might have a faster and more cross-platform. Yeah. I consider idea about using soft float one of the best for instant remedy. GCC appears to already have a soft float implementation. Check out the Stack Overflow to see how to use on x86. Current PCs are beefy enough to handle software floats. If required, we could even adjust it to replicate the old behavior. I tried using msoftfloat on GCC12 and the generate assembly looks just fine without any FPU instructions. Also for xfer routine seems to use a pure value stored in the float. So even a floats versus would result in a synchronization failing, even though it's such a small difference that no one would notice and would likely disappear in any operation with a float of a higher exponent. Don't even see an error accumulation as a likely reason for the desyncs. My personal opinion is to take one of these approaches. If breaking compat is considered acceptable, get rid of floats in game logic. Whoa. Preferred as it's the easiest to understand. Quantize the floats. Yeah, read the C++ documentation, try to figure out if round F and core are well defined. Yeah. I'm fine with going this direction of like trying like to figure out if massaging the floats will decrease desyncs, but I think before that we should figure out try to figure out if we can locate the origin of the desync. I would expect that this is possible. I haven't studied this yet because I'm still busy compiling and so on. Yeah, but I expect that we could build a lock where we can see at which place exactly something goes out of sync. It's probably a more involved change to add all this kind of logging, but maybe we can do that. And then if it comes from a float, then from floating operation, then we should be able to see it, right? But I don't think it's necessarily just floats. I think there's also a good chance that it's uninitialized variables. That could be a source. And I think also logical bugs. Logical bugs where maybe something runs on just one client. Some stupid logic, right? Like if player is that, then do this or something, you know, some really stupid logic. That I think is also possible. But yeah, I can't say. So we need some debug for this. Okay, we still get compile error. Holy warning. Type name first seen using class, now seen using struct. Oh, hold on. Class now seen using struct. Oof, okay. I think we made a mistake by adding this one here. We need to put this one here. Let's put this down here. Let's do that. And let's do that. Okay, still erroring. Man, what is the error? Is open. Function does not take 2 parameters. Oh. 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 Oh, that is interesting. That's interesting. So here it's somehow different. Huh. Well, then we say if that, else, and if. There we go. Why that discrepancy? I have no clue. No clue. So yeah, the cutting edge. Cutting edge compilation. Okay. Precision decrease. Last step should be easily testable by excluding LSBs of the mantissa. What is LSB? Last signed bit. Last signed bit. Least sign. I don't know. Least signed bit. Last sign. I don't know. Well, someone mentioned just send a snapshot of all floats from the lobby master to the clients in certain periods. I wouldn't bother with trying to get the floats calculated exactly the same on each client. Why is there this button here? Consideration we need is floating point contraction. So we likely need FFP contract off for Clang. FP strict. Oof. Soft float. Let's see what that is. Software float. How's the Berkeley soft float port for float 8 support for pulp? Building soft float for now running make, blah 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 blah. No optimizations. Okay, so it's really slow then probably. Soft float. Define one of the following. If your architecture supports reasonably fast divisions. Division results from a lookup table. Okay. This is most likely the fastest option since there's only 16 entry. Yeah, okay. None of the above to pull the reciprocal value of the second operand from a LUT, which is then multiplied with the first one. C. Float AT for float numbers. Huh. Wow. Flex float. What is flex float? It's flexing. Boss float. Flex float values have this format: sine, 1-bit, exponent, mantissa. Okay, so the way I understand it, the flex, the soft float basically replaces all the hardware specific floating point implementation, or let's say platform specific. I don't know. Is it hardware? No, it's platform, right? The platform takes care of. I'm not sure how this floating work. I would assume. Hold on. I mean, a CPU instruction, so it is hardware bound, no? I don't know. I mean, you have this IEEE standards that defines how a float is working. I don't know. I would assume that all floats would have to behave the same on all machines if they adhere to this IEEE standard, no? I don't know. can read this here. This looks like a nice article. Okay, what about the compilation? It's still ongoing. Okay. Set FP mode. Set floating point round mode to chop, which only comes into play when precision is exceeded. This is necessary for the fast flow to int routines and elsewhere in the system. Also set floating point precision to low. It could be anything as long as it is consistent, really. But this is in the vain hope of any slight speed boost. Okay. What if other part of the game's code changed from the default set FP mode to another mode while the game is trying to calculate the state CSC? Would that happen? The code is altering the FPU's behavior in ways that can easily lead to subtle differences in numerical results between platforms or even runs. Here are some issues it can cause. Rounding mode differences. Although the comment mentions chop truncation, the code currently sets a rounding mode to round to nearest. If parts of the game's logic expect truncation, or if different modules assume different rounding modes, even slight differences in rounding can accumulate over many calculations, leading to mismatches. Precision control effects. By forcing a low precision 24-bit, the code reduces the accuracy of floating point operations on platforms or CPUs with different default precision settings, blah blah. The results can diverge, especially in iterative calculations of physics simulations. Okay, this looks to me like this was AI generated, this response. Maybe. Platform and library differences. Proton Wine emulation layers may not replicate the exact behavior of the original Windows FPU settings. Differences in how these platforms handle the FPU control word or default to using SIMD instructions can cause consistent mismatches. Determinism in network games. In multiplayer scenarios, even tiny differences in floating point mass can lead to desynchronizations. Yeah, if one player's system computes values slightly differently due to the FPU settings or hardware differences. Oh, okay, so hardware, yeah. Then the game state can diverge, which might be what you're observing. Legacy code assumption. The game, being from 2003, likely assumes a very specific behavior of the floating point unit based on the hardware and compiler of that time. Modern systems with different floating point units, optimizations, and even different default FPU states can break those assumptions. In summary, the forced settings can lead to non-deterministic behaviors across different systems. This is likely why you see mismatches in calculations among players and consistent discrepancies when using Proton Wine. Addressing these issues might require ensuring consistent floating point settings across all environments or revisiting the game's reliance. Well, what one can do is... Yeah. DirectX CMake sets the FPU internal precision in running mode. As DirectX is not guaranteed to leave the FPU in a good state, we must call this at the start of game logic update and anywhere that touches DirectX inside game logic loops. Oof. Okay. Load screen. About the DirectX FPU messing, apparently this can be prevented too. FPU preserve. The multifactor can be one of the mismatch causes. That's a nice research here on the matter. I like it. Yeah. Yeah. Good. What about compilation? Oh, we got an error. Cannot open include file time API. Okay, that's what we added. Yeah. Let me see. Time API. All right. Time API. Let me see. In which in W3D display. Yeah, time API. W3D display, no such file. Okay, so if we remove that, does it still compile here? That's a big question. Let's see. It does, so we don't need that shit. Okay, I don't know why we added it then. Let's remove it then. Where did we add it? I think here, header include errors. There we go. D3DX math. Yeah, okay. So we target this change, advance, fix up, and we remove that again. There we go. Save. Ta-da. Okay, and commit. All right. All right. Okay, what does it say? For a 32-bit unsigned int, that's 1 divided by... What? In single precision, the resulting float might be very close to a very small number, but the exact rounding could differ slightly on different architectures, or if the FPU is set to a different precision mode. If two machines do not produce bit-wise identical results, the final delta times something can differ in the last bit. Over time, these tiny divergences can yield different object positions or ballistic outcomes. Yeah. Why is that subtle? On older x86 hardware with the same control FP settings, all players got the same rounding. On Apple Silicon or modern x64 SSE, the results may differ by 1 ULP, unit in the last place. So yes, the real random calls can cause mismatches if the FP environment is not forced identical. Okay. I guess it's a strong lead here. It's a very strong lead that we need to do something about the float math. Yeah. Yeah. What about this article here? The synchronized code and recall engine is deterministic, therefore certain considerations must be observed when working in these areas of code. There are a few programming practices that should be observed in the engine's simulation code to help avoid introducing desyncs. Use the recall provided random number generator function. Use only stable sorting algorithms. For example, sorting algorithms that maintains the relative order of the items with equal sort keys. Okay, so no unordered maps. Avoid relying on sort of order of strings. Different locales can have different sort orders. Okay, interesting. Do not call functions as arguments to other functions. That's a very nice wiki article. I can already tell. This is a nice resource. We can link to it. I didn't read all, but I already like it, so let me put that here for eyeballs. Avoid relying. Okay, do not call functions as arguments to other functions. The order of the calls are not guaranteed. Okay. I see, I see. Ah, that's, yeah, right. Huh. Instead, call them before the function and store the return value in a local variable. Ah, yeah. True. It was random, yeah. This example will risk a desync. Do something. Wow, okay. Instead, do this. Wow. Right, because the compiler can reorder this shit. Yeah. Multi-threading. Multi-threading parts of the engine may offer the opportunity for better performance. However, there are several situations that can cause the engine to desync, so avoid the following. Do not trigger script callbacks during an MT, what is that? MT section? Main thread section? I don't know what that is. Multi-threaded section, I don't know. They should not use acronyms. At least not without like some information what that means. Scripts, whether COB, BOS, Lua, or LUS, are not thread safe. Collect the calls that need to be made and issue them in a preceding single thread section. That makes sense, yeah. Synced parameters must not be modified in an empty section because they update the sync checksum on update. Store the new value in a separate parameter and apply the new value in a processing single thread section. Whether a parameter is updated when visited per job, the parameter needs to be expanded in an array with a number of entries equal to thread pool max threads. This allows each thread to tracking visiting the parameter without interfering with other threads' visits by using an index equals thread number. What? When a parameter is updated when visited per job, the parameter needs to be expanded in an array with a number of entries equal to threads. This allows each thread to tracking, visiting the parameter without interfering with other threads. I have no idea what that means. That went right over my head. I have no idea. Pay careful attention to whether a job output can influence an input into another job. For example, don't move units if the jobs also check the unit's position. Yeah, right. That's race condition. Beware of lists resizing and potentially reordering the elements as a result. Lists resizing. What kind of lists? Huh? I don't know what kind of list would do that. If you're talking about std list or vector, they don't reorder. That doesn't happen. No, I don't know. Maybe they have some structure that they reference. I don't know. SSE instruction: do not use functions. I don't know how to say this word. Reciprocal. I don't know. Intel specified a maximum error guarantee, which allowed them to make some adjustments depending on the need of each processor family, but that can result in different results at the bit level. Do not use the following SSE. Okay, it's fair. FPU. The engine uses a strep flop library to set up all FPU-related CPU-bound hardware to ensure that regardless of whether a compiler has used SSE or FPU, general floating point calculations will conform to the standard. This is important because most third-party libraries are pre-compiled to use the FPU rather than SSE. Strep flop library. Okay. The engine also checks multiple times in each sim frame that the FPU options are correct. Okay. Debugging sync errors. Oh, that sounds interesting. Let me make this larger. Debugging sync errors. Let me see the compilation, by the way. Oh. Comsup. Oof. Why is this not found? What is this bullshit? Ah. There we go. Okay, so we need to guard this. If is vs6 build, if not is vs6 build, then we put that in there. And if, there we go. There we go. Good. Let's check that. Okay, but that was already at the linking step, right? So that is very promising. I think it compiled through without any errors. It's pretty cool. Good. I think we made very good progress so far, but we are not done. Not done. Not at all. Let's get back. These things happen when simulations give different results for different clients. Currently, it is detected by means of checksumming crucial data on every write. This checksum is then transferred to the host, who compares them to his own checksum. For purposes of debugging, the sync debugger stores every such write with some debugging information. When a desync happens, the write history is compared on every client, who then sends locations where computation has given different results. The location is then resolved to line numbers of the engine source, which should provide information about the nature of the desync. I like that. First of all, before trying to find a sync error, you should make sure that running signal nans equals true. Works without getting zig FPEs, and while grinds doesn't detect invalid reads. Check for nans. Signal nans. Recompiling Spring. Run Spring, and ideally, if you have a replay which desync, run it with a nan checking Spring. Check for memory corruption, yeah. Man, these guys have some really advanced tooling here using BuildBot. Nice. Make sure every player who joins has this executable. It's not needed to have it at the time of joining the battle, but when the game starts, everyone must have it. Expect random undefined behavior otherwise. Okay. Let me, this is very interesting. Very interesting information. www GitHub slash the superhackers slash generals game code issues mismatch implement debug reference on mismatch detection strategy. Maybe you can is this also with logging, or what is this? Checksumming transfer to the host. Stores every and some debugging information. Yeah. Okay, so it's similar to. Let me just add it here to the top here. Reference on mismatch detection strategy. Save. There we go. Good. And we still get an error. Edit window. Oh shit. Right. the tools won't compile. Right. Right. Oh. Okay, it looks like we should fix the bit test thing for all 0-hour files, including tools. Yeah, okay. Bit tests. Let's open CMake. GenZH. Let's configure and generate the 0-hour tools so we get them into the solution. Generate. Okay. Reload. Okay, let's search for bit test. Find all. Oh yeah, there's still a bunch. Maybe more than a bunch. Yeah, okay, let's fix those as well then. Bit test. There we go. Bit is set and replace all. 164. All right. All right. Let's see. Bit test. Bit is set. Okay, then we take these guys and we stage them for now. Let's rebuild here. Beyond all reason also has wiki here with probably useful info on many things. Good. Then let's see if that compiles through. Telling a CPU to sell everything will also make them sell tech buildings like oils. Okay. Oh no. The feature requests coming in for Navy units. That won't happen. I don't think so. I don't think so. There's so many other things to do. And it's not part of the game core loop. So I don't think that will happen. Unless there's one person who specifically specializes on naval units and only wants to work on this. Otherwise, I don't see it happening. Yeah. Yeah, and if it would only be world builder units, right? Nothing that's on the standard factions. At least not now. Restoring the cut boss generals. Yeah. So this issue here, this one, telling a CPU to sell everything will also make them sell tech buildings like oils. This sounds like an executable issue. Not 100% sure. I will for now add executable maybe. I'm not sure. If it's not an executable issue, then we won't fix it because, well, this patch is only for 0 hour, it's not for generals. Yeah. Yeah. Good. Still compiling. Wow. All right. Okay. Okay, my expectation is that this will run through now, because the game is already done building and it seems to have been successful. Yeah. And let's see. So this guy here, let's what is it? Bit test. This one, advanced, create a fix up commit. There we go. All right, and then we have this one. So this change would have broken vs6 builds. Can we perhaps say let's stash this change. Stash. Let's rebase. Okay. Then upgrade to C++17. Let's let's do a stash pop. Let's add this to a dummy. Hold on, STL port. STL port. It's this one, right? Yeah. Let's do here advanced fix up commit. Stage commit. And then we have this one. We have this one. So this change goes in this one. Fix up, commit, and then this one. Let me find this here real quick. Let me take that. Let's just copy it here for now. Bear with me. Then let's do stage. Let's make a dummy commit. Dummy. Then we do rebase, interactive auto squash, rebase. And then we do reset current branch to here, mixed. And that should give us the files back and remove the commits. And then we do support. So this guy. So this one is wrong. Okay, so what we need to do is we take this guy and we take this guy and this guy and we take this guy. This guy. So we would have that and that and that. Is vs6 build false? Or we say if ms what if MSVC version less than this, if not less than that. I don't know if we need these. I'm not a fan of that change. I would like to have one change. How about print some information? Yeah, how about we take... how about we... Boah. Oof. Oof. Yeah, we can... Yeah, I think what we can do is we can take this guy and this guy and this one and this one. And then yeah, I think we can add it to here. Create a fix-up commit and add this one to that, right? I hope so. Print some information. Okay. Still compiling. Okay, and then, so now we have these guys left. So before it was like this. Let me see. MSVC. So it was like this, and if, but it should have been this. Like this, right? Yeah, it should have been like this previously, where we added the multi-threaded builds. Where did we do that? Oh, we added it somewhere later here. Here. Okay, then we create a fix-up commit on this one. And we do if not is vs6 build, MSVC, if MSVC, multi-thread build. Yeah. Then we do commit. All right. Then we have that, and then we remove this guy and move it like so, and then we add this stuff here. Yeah. Now we have a clean upgrades. Yeah. And this is upgrades to C++ 17. There we go. There we go. Okay, everything is clean now. Stage commit. There we go. Good, and then we can do rebase. Hopefully that goes without errors. Let's see. Yep, perfect. Good, that one succeeded. Congratulations. Let's see if that also builds through. Yeah. Okay, that's great. That's great. Oh, were there errors? Hold on. Oof, I see errors here. Oof. Oof. Ah, because it wants to build the tools. Yeah, okay, hold on. Cancel. We haven't fixed the tools yet. Configure. Generate. There we go. Good. Reload. What's the time? Just 2 hours 24. Felt like more than 3. Huh. Time goes slow. Okay. Okay, so then let's compile that bad boy. Yeah. So my expectation is that this succeeds now, which means we will have all targets building on vs6 and 0 hour building on C++17 right now. Next step will be C++20, and then I think we can open the pull request. Making good progress. Making good progress with compile. Game 0 hour compiling on vs6 plus vs22 C++17. C++20 is up next. Then I will open pull requests for initial eyeballing. Okay. Yeah. Then next session we will take a look at the C++20, and hopefully we can sort that. And if we do, then I think that's great. Make the pull request, and then yeah, then afterwards we can do the 0 hour tools, I think. And then yeah, and then after that we could then do the generals. Yeah. Okay, fantastic. Fantastic. Now the big question is though, that is vs6 still multiplayer compatible? That must be tested. Maybe I send the generals.exe to the testers and ask them to test it. Yeah, because we have made quite a number of changes. Yeah. Okay, that has succeeded. Great. Good. Yeah, fantastic. Fantastic. We do have a lot of warnings here, but we don't care right now. That's fine. That's fine. Good. I think that's very good progress. Good. Then I will take a break here. Has been 2 hours 30. Close. I wish you a great day or night. Until next time. Goodbye.